Hey everybody, this is Larry. This is me going with Q2 of the weekly contest 326, distinct prime factors of product of array. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem. So this one, there are a couple of things you have to know, but otherwise, it should be straightforward, but only if you know them. So maybe not. Yeah. Um, the first thing to observe is that each number is less than 1,000. For me, what that points to me is that I can do an square root of n algorithm. And actually, now that I think about it, the two prime problems, and technically, I guess even Q1 was not prime, but like divisible e thing. So that's a really weird problem set. But yeah, given that each number is 1,000, you can factor each number, by going up to the square root of n, which is of course 33 square, give or take, right? And what does that mean, right? But basically, the idea here is that you don't, if you're not careful, you would, and you can't really do it anyway, to be honest. Like, you'll find this out very quickly. Maybe you could do it in Python, but it wouldn't really work. Is that you could just, what they tell you is that you want to find the product of all these things and then prime factor them. But really, because multiplication is commutative, you can think about it as, for example, if you have this number and you're trying to get the product of this, actually, I could, what you can do is just factor them, right? So this is this is actually kind of terrible to do, right? And then of course now you can, if you write it out this way, where you factor each number, now you have factorized. I missed the 2 and the 3. You factorize this number, and then now you see it this way. And of course, what you realize or what you can observe is that you don't really need to find the product of the original numbers. You just have to look at all of them and then just find which ones are prime, and that's pretty much it, really. And then you just put them in a set as I did, and then find a distinct number of them. This is what I did. So for each number, as I said, I start with 2. While if I could divide it by that number, I do it, and then I increment afterwards. All the way up to the square root of square root of x. And if there's a remainder, then we add it to the set as well. And then we just return the length of the set. That's pretty much it. So what is the complexity of this algorithm? Obviously, this iteration is O of n. And here, as I said, it's going to be O of the square root of the range, where the range is 1,000, right? So basically, this is O of, let's say R is the range, then R to the square root, right? So then this entire thing is going to be n times R to the square root time, and space is just in a lazy way O of R space, right? Say, because for example, this one can, obviously it's way less than this if you know anything about primes, but for example, it can only contain up to 1,000 numbers in any case, even if you just take non-primes and everything. So that's why this is O of R space. That's pretty much all I have for this one. You could probably be a little bit better on the space as well. You probably can do an O of 1 space if you do the loop in a different way, meaning that you count. You basically divide. Yeah, if you do all the prime numbers up to 1,000 or something like that, and then you just check to see each one whether they count on each number. So you could do it that way in O of 1 space. Maybe depending on how you write the prime algorithm as well. But this is what I have though. So let me know what you think. That's what I have. So stay good, stay healthy, and you could watch me solve it live during the contest now. It doesn't have a 0. That's what I was looking for, actually, because that would have been a very sad wrong answer. Distinct prime factors in the product of the elements of the, okay. Distinct prime factors. Okay. 1,000. So go up to 33. That should be fine. Okay. One. Yeah, thanks for watching. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this problem, this explanation, this contest, whatever you like to talk about. Yeah, have a good new year if you're watching this near the new year. And even if you're not, still have a good new year. That's what I have. So stay good, stay healthy, take good mental health. I'll see y'all later and take care. Bye bye. Boop.